Anybody? All right, let's do some, so where are we right now? Near the end of the year, function word problems. We did that. Uh-oh, there it is, inverse functions. We got to talk about inverse functions, evaluating, finding, and then you're going to have some interleaved practice. Look at that briefly. All right. So let's start out with evaluating inverse functions. So we know about inverse operations. Inverse operations are the opposite operations, like addition, subtraction, multiplication, division. But inverse functions are, they're based on the inverse operation. So like, we define them in a different way. Okay, so let's put basics here. Okay, so the -1 exponent that indicates inverse function. All right. So we say this, we say f of x. This, we don't say f -1 of x, we say f inverse of x. Okay, and the inverse functions, when you compose them, you get x. So how does that make sense? Oh, here's a good. Don't write that down. Write this down. If we have f of x has the coordinates x, y, here's a real simple, nice, easy way to think. Okay, what is f inverse? You're probably like, I have no idea. You've told me a few things, but I have no idea. Here it is. F inverse is y x. It's a reflection over the line y equals x. Let's write that down. Inverse functions are reflections over y equals x. And that's exactly what they are. The line y equals x, we know, is a line with a slope of 1 and a y-intercept of 0, right? They're running fast. And so if you reflect a point across that line, those 2 points are inverses. All right, if you reflect a function across that line, you got inverses. Okay, but that's just some background knowledge. What we are really going to use right here, we're going to use this handy dandy trick about inverses. So y equals x, x equals y. So what is the f inverse of 7? So this is our x value. So let's make the f inverse table, and then this will make this really easy. Okay, so what's the f inverse table? It's just going to be 7, 14, -10, -6, -15, -1. Now I got to erase. I keep pointing. I need room for my table. But you should have it written down. All right, where was I? 14, and 10, -4 and -10, -9 and 3. All right, so there we go. So what's f inverse of 7? So that is, what is the value? So then we go to the f inverse table and we look at x of 7 is 14. So that means we want to find f inverse, and f inverse of 7 is 14. So now what is f inverse of 14? Now I'm going to go to do this one. Where's 14? 14 is here. 10. So F inverse of 14 equals 10. Yeah. All right. So what's F inverse of -4? So now we just have to go to -4, and it's -10. Just in case you think I'm completely crazy, let's put them in. Let's see. 10, -10. All right. So background info, but let's do one more. Ooh, graphs. Okay. So I'm just gonna switch the x and the y, right? Invertible function g. That means it has an inverse. Not all functions have an inverse. What is g inverse of -8? So what is g of -8? Well, actually, we don't want to know what g of -8 is. We want to know what g inverse of -8 is. And so we need to know which one of the, so remember that is asking us for a y value. That's asking us for a y value on g inverse. Okay, and it's giving us an x value. But we don't have the g inverse graph. We have the g graph. Okay, so if they gave us an x value on the inverse graph, then actually on the g graph, we know our y, that is a y value on the g graph, right? Because the x values on the inverse graph are the y values on the regular graph. And the y values on the regular graph are the x values on the inverse graph. They're switched. All right. So let's go to where y equals -8. Oops. Y equals -8. Right here, that has an x value of 7. So we know that we have a point at 7, -8. So that means I'm recording a video. All right. That means on the inverse graph, we have a point at -8, 7. You see, the y values are switched. Okay, so let's rewind that. They gave us an x value, and they want to know a y value on the inverse. So if they gave us an x value, then they gave us a y value on the original. You're going to have to do this one a few times to get that, because, you know, it's like this and that and this. Oh. 7. It's 7. All right. Okay. Let's do one more. So now we want to drag the segment across. Okay. Oh, wow. They just keep having different functions. So here is y equals h of x, and we want to drag the endpoint so that we have our inverse. So -8, 2 is one of my points. So I'm going to put a point at 2, -8. 2, -8. And that is switching the x and y. And this point is 3, -4. So I'm going to put a point at -4, 3. There we go. Did I do it right? I messed it up. I could feel that I messed it up. All right. This is there's a 1. Okay. Okay. So what's going on? Come on. There you go. All right. It was a 1, -8. Okay. All right. Let's do this. The table below shows some inputs and outputs of the invertible function f with the domain of all real numbers. Find f inverse of -2 and f inverse of -1. So what are we going to do? We are going to make the f inverse table. x f inverse. And so we're going to put all the 9, -2, -5, -1, 1, 11. And then 5, 3, 1, 18, 0, 9. All right, so what's f inverse of -2? Well, let's see, that's 3. And f of 1 is 0. 3, 0. Let's end on a good note here. All right, so now let's move on. You can try that one. You can post in the organizer. All right, this one, you would think maybe this is more confusing because it's the next assignment, but it's actually less confusing. We're just going to do a simple little process using that rule that f of xy is equal to f inverse of yx, right? Yeah. So what is the inverse of the function? So what we're going to do is we're going to write, first we're going to replace this with the letter y. Okay, so we're going to write y equals 5x minus 2. So write that down. Replace function notation, g of x with a y. Then switch the x and the y. Write that down. Switch x and y. So I'm going to write x equals 5y minus 2. Then solve for y. So I'll write it. Switch x, y, solve for y. All right, so we're going to distribute 5y minus 10 equals x. Then we're going to put the 10 on the other side, so x plus 10. And then we're going to divide by 5. And so that's 1/5 x plus 2 equals y. So the inverse, according to my calculations, is 1/5 x plus 2. Ta-da. All right, now quadratics, quiz 3. Let's see what kind of things we have. Okay, solve. So you are going to use the quadratic formula, or you can factor, right? All sorts of things like that. And this is graphing. Oh, okay. We just did this like a few weeks ago. So you got your 3 forms: vertex form, factor form, and standard form. Go back, find that table, give these a try, and you might remember them forever if you get them to 100% again, a few weeks later. All right, I'll see you in class.